Right, so here's question 9. Right, what you've got is you've got a quadratic. They're asking you for the axis of symmetry and write down the coordinates of turning point. Your turning point, you look at these two values and you always flip that one in terms of the sign. So this is your essentially your x coordinate, but we look at it as -2, and this is your y coordinate. Okay, so that one you look at the sign and bring the sign down with it. This one you have to at the last moment just flip it round. Okay, so that's your turning point. Now that means, so remember, say that was your parabola, right? And your turning point is -2, -4. Your axis of symmetry is just the vertical line for these examples. It's your vertical line. So it's basically where when x equals -2. So when they're asking you to write down the equation, you just look at axis of symmetry. Just say x equals -2. And that's it. So if you go on to the next question, question 10. So question 10, we've got x plus 5, x minus 2 equals 0. Now there's two terms here and two terms here, so you end up with 4 terms, right, when you expand it. So I'm going to say that times that, and that times that is x squared. I'm then going to press the wrong button. Right, should be okay. Right, so I'm then going to say that times that, which is going to be minus 2x. I'm then going to say, well, times that by that, which is plus 5x. And then last but not least, we're then going to times that by that, which is going to be, no, we're not, we're going to times that by that, okay? And that's going to be minus 10. So we just bring all that together as x squared plus 3x minus 10. Okay, just double check, x squared, it's there. That's you. The reason why I was doing it that way is quite often you're getting taught the method called FOIL, okay, and that's first, outside, inside, and last, right? But that's essentially, you end up always with 4 terms, and then you essentially just collect the like terms together. So there's an x squared there, and collect the x's together, and then obviously you've got a number there as well. But that's your answer for that one. If you then have a wee look at question 11. Right, so x squared minus 6x plus 3 equals that. Right, your quadratic formula, you need to use this one. Okay, so let's get your wee quadratic formula. I think it is minus b plus or minus b squared minus 4ac. Divide that by 2a. Hopefully that's correct, should be. Right, so what we've then got is you then just put these values in. So what you have there is you've got, that's a equals 1, b equals minus 6, c equals 3. So what we then do is we just then put these values in. So minus 6 or minus 6 plus or minus 6 squared minus 4 times 1 times 3 over 2 times 1 is that. Okay, so minus 6, that gives you 6, plus or minus 36, minus what we've got here is 12. Divide that by 2. So we can even, I'll just take that down here. So you've got 6 plus or minus, that is 24. That's 2. So we can say one root is going to be 6 plus the square root of 24. Divide that by 2. And the next one is going to be 6 minus the square root of 24. Divide that by 2, and you just put these in the calculator. Probably easier said than done. Right, so what we do is we go 6, see if you can actually see this, 6 plus, and then where's my square root sign? Square root, smashing. Right, I'm just going to use the calculator I've got on my desk, right? 6 plus the square root of 24, divide by 2, that's going to give you 5.45, and then the next one is 6 minus the square root of 24, divide by 2, that is 0.55. And that's to 2 decimal points. Right, so that's the answer to that wee question. Right. Hopefully that equation seems fine. Next wee question is question 12. Right, the nature of the roots, that's this equation here. See the wee discriminant? That was that part of that quadratic equation formula. So it doesn't give you the roots, it just tells you the nature of the roots. So what we've got here is we just substitute these values in. So I'm going to choose another wee colour, press the wrong button yet again. So if I go A equals 5, B equals -1, remember always look at the sign outside, and C equals 11. So we end up with this is -1 squared minus 4 times 5 times 11. That equals 1 squared minus 4 times 5 times 11. 4 times 5 times 11. That seems okay. So that gives you -219. So if it's actually less than 0, then there's no real roots. So you end up having a wee parabolas floating about. It's not going through the x-axis at all. Right, but that's the wee rules that you're needing to remember. I'm just going to double check because that seems a bit of a, well, not odd, but certainly different to the ones you're normally used to. So b squared, that's -1, so that's 1 squared minus 4. Seems fine. Right, so that's question 12. And try and get rid of some of these previous ones. Right, this will be the last one because I'll be running out of space. Right, so question 13. See this one, they try and trick you into with a wee scenario. Now the wee scenario is better than the one I'm drawing, but what you've got is you've got a flagpole, got a wee flag waving in the wind, right? And they're saying, is it vertical, right? So now, you know, if something's vertical to the land, what you know is it has to be straight up. So you basically have to think about that being right angle. Now they're quite nice because they actually give you these values, right? So it's essentially what you've got a triangle. Okay, so you've got a wee triangle here. That's absolute disaster. Right, so you've got a triangle, right? So what you should be thinking of is calling that C, because we're going to use good old Pythagoras, right? And what Pythagoras came up with is saying C squared should equal to whatever A squared plus B squared is. So that to bear in mind, we've got 13 squared. That should be the exact same value as if you square 10.8 and you add 8.1 squared to it. So you then get your calculator and you realise when you type in 13.5 and you square it, what you've got is 182.25. And then if you go 10.8 and you square that, what you'll find is that is 116.64. And if you take 8.1 and you square that, you'll find that that's 65.61. And you'll fastly find if you add these together, 182.25 is the same on the left hand side as it is on this side. So therefore it's vertical, right? And the reason it's vertical is basically the sides obey the theorem of Pythagoras, right? So that's when they give you a wee scenario. Think about, you could even redraw it as a triangle and just use the properties that you know about a right angled triangle, okay? But that's essentially how you answer that wee question. And I think I'll give the next one a wee go, right? So add new layer. Hey, question 14, might as well give it a wee go. Hey, question number 14, this is me trying to draw a circle. This wee circle kind of looks like this. What you've got here is you've got 130 degrees from there to there. And these are tangents, right? So we know, right, so this is a tangent. And we know if a tangent just brushes past the circle, certainly not as bad as that. So we actually know that this radius will be meeting the tangent at a right angle. So these two sides are right angles. So if we actually split this in two, that's what happens when you rush stuff. You start making mistakes. You end up getting a triangle like this. So this is your right angle. Now this is 130 divided by 2, right? And that is going to be 65 degrees. That's 90 degrees, so we don't have a clue what that is, but we know that 180 degrees, all these angles have to add up to that. So if we subtract 90 from it, if we then subtract 65 from it, what's left is the wee missing angle. So 180 minus 90 minus 65, that's 25 degrees. That wee bit there, 25 degrees, but we're trying to work out this angle. So yeah, essentially 25 times 2, and that gives you 50 degrees. So this whole angle is going to be 50 degrees. That's how you work that one out. One of the worst drawings I've ever done, but hopefully when you look at the actual sheet that you're given, it makes sense, right? But that's essentially how you do that. So that should be all your homework done. Sorry about the rush.